Hello everyone, welcome back to the channel. In today's video, we are going to go over another question on Codeforces, that is inflation. So let us quickly go over the problem statement. So you are given a statistic of price changes of one product represented as an array of n positive integers p0, p1 up to pn-1, where p0 is the initial price of the product and pi is how the price was increased during the ith month. Using these price changes, you are asked to calculate inflation coefficients for each month as the ratio of the current price increase Pi to the price at the start of the month. So in this second paragraph, what they're basically asking is us is to calculate the inflation coefficient. Now the inflation coefficient is basically Pi Pi divided by P0 plus P1 plus which goes on to P of I minus 1. So this is the equation that they are expecting us to calculate. Now your boss said you clearly that the inflation coefficient must not exceed k%. So here they're saying that inflation coefficient must not exceed k%. So it is basically saying that it must not exceed k divided by 100. So you decided to increase some values pi in such a way that all pi remain integers and inflation coefficient for each month does not exceed k%. So in a scenario where this condition is not satisfied, what we can do is what they are expecting us to do is they're expecting us to add some value x to the denominator such that this condition will become true. Okay, so this is what the third statement says. You know that the bigger the changes, the more obvious cheating. That's why you need to minimize the total sum of changes. What is the minimum total sum of changes you need to make all inflation coefficient not more than k%? So basically what they're saying is the x that we have to add must be as low as possible. So this was the overall question. Now I hope the problem statement was clear enough. Let's have a look at the input. As usual, the first line contains t, that is the number of test cases. The first line of each test case contains two integers, that is n and k, that is the length of the array p and the coefficient k, which will help us determine the k%. Okay, and the second line of each test case contains n integers going from p0 to pn-1, that is the array p. Now in the output, they are expecting us to print the total sum of changes that you need to make all inflation coefficient more than k%. So we have to print x as low as possible, and x must be as low as possible. So here they have given us an example and as well as the output. So let's take this let's try to solve the question with the help of this example, and we'll discuss simultaneously discuss the approach. Okay. So this was the problem statement. This was the condition that was given to us. That is, pi divided by p0 to pi minus 1 must be less than or equal to k divided by 100. Now this condition must be satisfied for all valid I. Okay. So we'll just modify this condition a bit. That is, let's say pi. Let me just copy this condition. Okay, I've copied the condition and I'll paste it here, and instead of writing p0 to pi minus 1, I'll put it in some variable that is previous. Let's call it previous sum. So previous sum is basically the summation of all previous values. Okay, and I'll take this example over here which we'll try to solve now. Okay, good. So as they have mentioned, this would be our initial price, and we have to calculate the inflation from starting from month 1, that is for 1 for 202 and again for 202. So starting from here, if we try to calculate the inflation coefficient, it would basically be 1 divided by 201000, and it must be less than or equal to 1 k. The k that they have given us is 1. Okay, so just uh, put it here. K is equal to 1. So the overall condition becomes k divided by 100 or 1 divided by 100, that is 0. Okay, just let me keep it 1 divided by 100. Okay, so it is obvious from after looking at the condition that 1 divided by 100 will be like 0.01, but 1 divided by 20100, that is again 201 into 100, would obviously be lesser than 100. Okay, so this condition is satisfied. Now let us try to look for 202, if 202 satisfies the condition or not. So it would basically be, a numerator will be 202, that is the rise in cost, and the denominator would be previous sum, that is the sum of all the previous elements from starting from p0. So that is 20100 plus 1, sum of all previous elements, and this is basically 20101. Okay, cool. Now if we try to calculate this with the help of calculator, you'll notice that this is somewhere around 0.0, this is 0.01, but the LHS is 0.0104, 4 and 3 or something, sorry, 0.043. So as you can see, the LHS is greater than the RHS and the condition is not satisfied. So in order to satisfy this condition, as we saw here, we must add some value x to it. Okay, so we'll do the same, that is we'll try to add some value x, 20101 plus x, which will help us make this condition true, 100. Okay, and for now this condition is not satisfied. Okay, so now we have to find, next task is to find the value of x. Now in order to find the value of x, there are multiple possible cases, like you can use binary search, which can also work, and it will work if you want to, but in this situation we'll not use binary search but just plain mathematics, which I think would be much easier. Okay, so if we move this whole term to the RHS and we'll shift this RHS to the LHS, the equation would become 202 divided by into 100 divided by 1, and which would be 20101 plus x. Now this is basically 20200 is less than or equal to 20101 plus x. So the value of x would be 20200 minus 20101, which is equal to 99. Let me write it down like this, which is equal to 99. Here we got the value of x. So for now the value of x is 99. Let me write it down, 99. Okay, now let us try to calculate for the third term as well. Sorry, 99. Okay, and we'll try to calculate it for the third term as well. So third term is basically 202 divided by, let me move it over here and I'll just copy the same over here for third term. So third term would be 202 divided by 20100 20100 plus 1 plus 202, which would be 20303. Now if we try to evaluate this equation, we can see that this would be the LHS would be lesser than RHS, and this condition would be satisfied. So we don't need to add anything in order to check this condition or like make this condition true, as this is already true. Okay, so this was the overall program. Now let us have a look at the code, and we'll just print 99. Yeah, so we'll just print 99, and as you can see 99 was the answer here. Okay, now let us have a look at the code. So in the code, what I am first I'm declaring two variables n and k and taking them as input. Then I'm taking in the array input in the array variable or vector arr. Then I'm declaring two other variables. One is x and the other one is psum. Psum is basically the previous sum that I mentioned over here, the previous sum. Okay. Then I'm traversing the array for all the elements, and for all the elements which are not the zeroth element, we are calculating the required amount. The required amount, what is required? So required here is basically here we took 20101 plus x, right? So instead of taking this, adding this plus x, I'm taking this whole term as required, and so here also it will be required, and once we get the value of required, what I'm doing over there is I have previous sum, right? So I'm subtracting the required amount from the previous sum, and that would be my x. Okay, so the previous sum over here I think was 20101. So 200 minus 20101 would be 99, which is one and the same. So this is what I am doing over here. I am calculating the required. Why I am taking the seal value I am taking because here they have clearly mentioned that pi should remain integer. So that is why I am taking in seal. And once we get the required amount, I'm subtracting it from the previous sum, like I told you here, and taking in the maximum among them, taking in the maximum where is it? Yeah, taking the maximum of x and the required minus previous sum. Now why am I taking this maximum? Okay, so I'll try to explain it over here. Let's say that the array did not end over here, and we had one more term, over here which was 300. Okay, so now if we were to solve this equation, that is 300 divided by 20303 plus 20303 plus 202 is 505. If we were to solve this equation, okay, let's solve this equation quickly. 300 divided by if we first try to calculate the answer, we can notice you will be able to see that this value is greater and the condition is not followed. Okay, so the condition is not followed over here. So in order for this condition to be true, we'll need to add some value x to the denominator, 20505 plus some required or x, and so that the condition would be true. Now if we were to find the value of x, it would basically be 300 minus 100 would be 20505 minus x, right? Now 300 into 100, so it would be like 3 followed by 4 zeros minus 20505 would be x, and x would be I think 495. Yeah, 495, right? So here we got x value as 99, right? And here we got x value as 495. Now if we take the value of x as 99, that is the minimum one, this would not satisfy this given condition. Like this would only increase the denominator by 99, but the required is 495. Like it would still need 386 values to be added. But on the other hand, if we take x value as the maximum as possible, let's say 495, then it will also cover 95 in it, right? So like if we take 95 over here, then 95 will also satisfy this condition over here, right? So we are taking 495, that is we are going with the maximum value. So this is what we are doing over here, the maximum value. And if you might be confused with the minimum term, like minimum total sum of sum, then don't worry, because this 495 that we got is the value of x that for this condition is as minimum as possible. Got it? Go over the video again and go over the problem statement again if it still confuses you. But this is what it is. Like x is the minimum value that you can add for this condition, like for this 300 month to be valid. The equation at this month to be valid. Okay. So this was it for the video. I hope you like the approach and the solution. So thank you for watching.